Hello everyone, this is the second part of the topic property of state. And in the first part of this topic, we learned that property is characteristic a system has. Property. And properties such as temperature T, pressure P, and internal energy U, and of course other properties can be categorized into two groups, namely intensive properties and extensive properties. And one way for you to decide whether a property is intensive or extensive is that just imagine you divide the system into two separated parts. For intensive properties, their values remain unchanged. That means remains constant. But for extensive properties, the values will change. Okay, so now I give you one example. I have here a solid with mass m, volume v, and density ρ at its initial state. State 1. And now I cut it into two equal parts. So it is a common sense that the mass and volume for each new part will be half of the volumes of initial state. So m nu here is equal to 1/2 of m, and the volume nu is equal to 1/2 of v. So we know that mass and volume depend on mass, so they are extensive properties. And what is about density? Since density is defined as the mass over volume, so we can now calculate the density for new part, right? Is equal to 1/2 of m over 1/2 of v equal to m over v equals the density ρ at the initial state. So the density is an intensive properties, do not depend on mass. Okay, and at the end of the video I also shortly introduced you the concept state, and in this video we will learn more about it. Consider a closed system here, and at a certain point we can measure, for example, the pressure P, temperature T, and we can also calculate the density ρ and the internal energy U. Of course, we can obtain many other properties such as volume V, entropy S, and so on. So if we have a set of properties, then the state of this closed system can be described completely. And in another words, very important, I will write it in red color. So at a given state, the system has a set of properties with its fixed values. So pay attention here, fixed. So if the value of any one property changes, the state of this system will change into a different one. So please remember this important conclusion. At each state, each property has a fixed value. It makes sense, right? You may know that density is a function which depends on pressure and temperature. So if we get a certain pressure P1 and the temperature T1, then we can calculate the density. And if pressure and temperature change, or even both two change together, the density will also change into another value. This value is only fixed with certain pressure and certain temperature. Okay, so as discussed above, I will introduce you a vital concept which is available for all properties of state, and this is point function, and available for all properties. And the point function has a unique characteristic, namely, if we want to know the change of state of one system from state 1 to state 2, and we only need to calculate the difference of property at two different states, regardless how system undergoes this process. So I will do here a little mathematics, and we calculate the change of state in way of integral here from state 1 to state 2 is equal to x2 minus x1, regardless how system undergoes this process. So in our daily life, for example, the room temperature is here 20 centigrade, 20 degrees centigrade at 8 o'clock, and after 1 hour the temperature becomes 25 degrees centigrade, and we'll say, oh, the temperature rises 5 degrees centigrade, and you just let 25 minus 20 and then get 5 degrees centigrade is delta T. But maybe the temperature T runs like this within 1 hour. 8 o'clock, 9 o'clock. For example, here is 20 degrees centigrade. Here is 25 degrees centigrade. Maybe the temperature runs like this. But you do not care. You just picked the points at initial state and at final state. And these 2 points are already enough for you to determine the change of temperature in this way. Right? So the conclusion that each property is a point function provides us an approach to determine whether a variable is property or not. So how can I determine whether a variable is property or not? I will give you 2 ways. So approach 1, a system has an initial state 1 here, and undergoes a process and then return to its initial state. So if the change of this variable equals 0, that means the cyclic integral of variable equals to 0. So then we can say this variable is a property of state. So the cyclic integral of variable equals 0. This is the first approach. And the second approach is, if the system does not undergo a cycle process, which means do not return to its initial state, and we can utilize another approach, the second approach. If the change of variable in its values between two states is single valued. So this variable is also a property of state. So this approach indicates that change of value of a property, I said, is path independent. So therefore, later if you have to solve the problems about change in value of any property, you can choose any path you like. But of course, I prefer to choose a path which helps me to solve the problems more easily, not more difficulty.